Thanks for the introduction. Thanks everybody for being here. Thanks to the organizers for this event. This is my second time here at PyCon, first time as a speaker. I'm a bit rusty with presentations, so bear with me. I hope not to be too long. But yes, so my name is Giacomo. I'm a data scientist at Overture. Overture is a technology company that works within digital transformation, cloud infrastructure, and in developing data-driven solutions for different type of businesses. And it's part of a bigger group of companies which is called Symphony Prime that was also present last year, and it was contributing to this same event. So today I'm going to give you an introduction to the growing field of location intelligence, and in particular on how Python can help us in handling certain type of data and information involving spatial location. So this is pretty much the overview of the talk. We will start with an introduction on location intelligence, try to define it, and to understand what it's useful for. And then we'll move to the second block, which is the main block of the talk that speaks about what we can do with Python in terms of data transformation, in terms of mapping tools, visualizations, and data enrichment. And then we will take a look at how we can use and apply predictive modeling as an approach to solve certain types of location intelligence use case. Just a little disclaimer though, this is not a talk about machine learning techniques. This is mainly about how we can work on a location intelligence project, exploiting different Python capabilities, and what we can do with it, pretty much only using open source tools, let's say. And then we will start really from just the location information, so just from geographic coordinates, and slowly we will build up a data set that then can be used for predictive analytics and to create business insights. So we will have a little simulation about this at the very end. So let's start with the definition. The shortest definition I could find is this: location intelligence is a form of business intelligence where you somehow make use of the location information. So it's about analyzing geospatial data to derive trends and actionable insights that then you can apply to different fields. So we will elaborate a little bit more on this, but the applications really, already you can understand that the applications of analyzing geodata is huge, starting from the weather forecasts. Just think about the amount of data that we use there, and obviously it's data that have a location component always in it. To industry, agriculture, there's something called intelligent farming, where you use analytics tools now to decide what type of treatments you apply to different pieces of lands according to their characteristics. To healthcare, just think about the pandemic and the ways to track the spread of a disease and try to limit it as much as possible. To anything else, logistics, supply chain, optimization, traffic, regulation, telecommunication, I mean, the list is endless until you get to marketing and geomarketing. So where to sell a product respect to another and why. So these type of things. And the amount of data that we can use is huge. There is a claim that says that 80% of all the data gathered and produced and gathered today contains a location component. And it makes sense if you think about it. I mean, every activity that we do nowadays produce location information, from taking a photo, running with a smartwatch, taking a taxi, anything. So now industries are understanding the power of location, and they're trying to leverage this amount of information to achieve strategic goals. And location can really provide an advantage for businesses, for example, in the way they communicate to their customers. They understand their needs, and they personalize the service, which is the key thing in marketing. So whenever you hear things about spatial, geospatial, GIS, geodata, these are all terms that refer to numeric data identifying the location of an object according to a certain coordinate system, usually latitude, longitude, and altitude. And they come together often with some additional attribute information, namely the characteristics of the objects that you're talking about, and or temporal information. So for example, the time at which that location exists or existed. GIS in particular, they're not just simply data, they are software applications for management of geospatial data, and they usually work in layers, and they allow you to build your own mappings. They are quite specialized tools, but they're not usually optimized for simple business analysis. So we're not going to use any of those anyway. We're just using basic Python to build our own stuff. So geospatial data types, there are many. The two main categories, I would say, are vectors, that are the most basic ones and the ones that we're going to use, that pretty much describe objects such as buildings, cities, roads, in terms of points, lines, and polygons, so in terms of geometric objects. And then there are other types like the raster data types that are a bit more complex because they have a matrix form, so rows and columns, and they're usually used in imagery. But pretty much any data that contains a location component can be classified as geospatial data. Anyway, we're going to use the first type with Python. Before doing this, let's set the stage a little bit, saying that one of the most common applications in modern location intelligence is probably site planning, retail planning. So every time you want to open a new shop, for example, or you want to relocate it or consolidate the business sites that you have, what you usually do is you try to combine the sales information, so the information on the performances of your business, with information about the area surrounding your business, such as, for example, demographic information of that area. And traditionally what you do is you use data such as offline surveys, census data, information about the traffic in the area, information about the possible points of interest that can attract your customers close to your shops, and then you put all these things together into analytics model with some already known and pre-selected requirements that experts know that are important for your business to thrive. But this approach is usually time-consuming, and especially it's non-dynamic because it doesn't adapt to the fast-changing market. And so the idea would be to try and use a more modern approach using AI and especially machine learning, where what you do is you use historical data on locations that you already have and try to teach a model to learn the correlations between the performances of your business and in the area, the characteristics of the area surrounding it. So what we will do now is we will start from a very simple data set. It's a list of places all around Italy that are cafes, bakery shops, off-license shops, and ice cream shops. I think it's all. And we are going to imagine that we need to place our products in the best ones for us, so the ones that are going to make our business rich. So we have a list of about 50,000 places all around Italy, and really the only information we have is, for now, is latitude and longitude. We also have the full address, but latitude and longitude will be enough for now. So the very first thing you can do, I mean, just to have an idea of the distribution of the places, is just plot them in a scatter plot, just treating latitude and longitude as numbers, not even coordinates. And with matplotlib, you can just plot them on a white plot, and since there are so many and they're pretty much distributed all over Italy, you can already reconstruct the shape of the country, just like that. So this is a legitimate first approach to how to visualize where things are. But obviously we want to use maps, so Python gives you many options for mappings. One of the main ones that we're going to use is Folium. Before that, I chose to try to have a go with Basemap, that apparently is one of the first ones that was used a lot in Python, and it's really an extension of the matplotlib library that has a bunch of data sets included, like GMT, GS, HHG, that are essentially data sets containing coastlines and political and geopolitical borders that then you can fill up with colors at different resolutions to construct your maps. So I don't know how much you can see here, but once you fill the lines up, you can construct continents, and then from there you can plot your own things. I decided here just to distinguish between 2 of the 4 categories that we had and color them differently. I think the blue ones are the ice cream shops. And so you can already see the distribution. You can see how many along the Adriatic coast, how many ice cream shops there are. I'm from there, so I can confirm it's plenty of those. But as you can see, this is a static map, okay? So we want to be able to play with it and explore more. So the next choice that I would make, I think it's one of the more flexible ones, is Folium. And Folium really is a library that gives you access to the mapping capabilities of another library that we heard about in the previous talk, the leaflet JavaScript one. But so in this way, you have the best of both worlds. You have Python to handle your data, and then this fantastic library for visualizations. And you can immediately, easily mark your places with circle markers. You can either cluster them together if there are many, like in our cases. And according to the zoom in, you can see more or less detail. And this is only really using the 2 columns, latitude and longitude, that we had since the beginning. You can even take it further, make it even more interactive, playing games like, for example, grouping them together. You can create in Folium different layers of data. In this case, if you want to group by cafes, ice creams, or off-license shop, you can create 1 layer each. And then with something like layer control, you can filter them out and treat them independently. So you can tick off one of those, and you would only see the category that you want. And again, this is just using 2 columns from our Pandas data set. Now, what if we want to do something more? What if we want to start making calculations? Calculating like distances or lengths or areas. In this case, you need to start using geometric objects. So a must-use library for this kind of things is Geopandas, I would say. Geopandas is something that makes your original Pandas data frame a Geopandas data frame, which means it creates a new column, a geometry column that puts together latitude and longitude into geometric objects, the most basic ones, in this case, the points. Each data frame, each Geopandas data frame should have at least 1 geometry column. It can have more, but only 1 will be the active one where you make the calculations. Another important feature about a geodata frame is the CRS attribute that needs to be there, the coordinate reference system. You need to specify that one. In this case, this is the basic one. It's pretty much the one that expresses distances in decimal degrees. But obviously, there are ways to convert them in meters, and we will see how. If there's no a CRS, you should include it somehow. There are libraries for doing that, like Fiona, for example, and these kind of things. Now, once you have the geometry column, you can start making super easy calculations. Like we take a couple of points from our data set, the geometry part, and then we can calculate the distance between 2 points that will be expressed in degrees, as I said. And to do this type of things, you should always include the Shapely model, super useful for this type of geometric operations. And then to convert and to project coordinates in another reference system, you can use something like PyProg, or Proj, stands for projection. And you can easily go from one system to the other and express the same distances in meter. One thing you can do here, just to try out, is to convert your couple of points into a line and then calculate the distance as a length, as the length of the line. It's exactly the same thing. And then you can get immediately things like the central point of the line, the centroid, for example. Another useful thing would be to calculate the distance between the line and an external point. Like think about your point as your cafe or your off-license shop, and you want to see how far it is from a street, for example, that you're interested in, right? This is very easy to do. Again, in degrees or in meters. So once you get these tricks, you start thinking about how many things you can do. We have seen points, we have seen lines, we need to see polygons now. Polygons are simply 3 or more points connected together by lines, and they create an area. And to play around with polygons, we're going to use momentarily another data set. This is some information that you can find online. these are the postal codes of Milan, in this case, expressed as polygons. And whenever you see a data set like this, you're probably using shapefile type of data, right? And these are very common, and they were originally created for working with GIS softwares, and they express the geometry and the attributes of your objects. They come as a package, and the good news is that Geopandas is very, very easy to handle this type of data. So again, with polygons, you can play the same tricks, find the middle point of your cap zone, find the area in different coordinates, the bounds, the perimeter, and so on. So you can do many things. Now with Geopandas, you can plot them just like that. In this case, we're plotting all the cap zones of Milan. We calculated the area, so we're colored them differently according to the value of the area, converting them in meters squared or kilometers squared. And you already have a visualization of your polygons. Now you can get fancier with this, and you can join Geopandas with Folium. Just with one line of code, really, you can obtain something like that. You just use the explore method, for example, and this will create immediately a dynamic map with Folium, and we'll stick the polygons on top, and it brings attributes with it. So just by going along with your mouse, you can pop up the characteristics of the area of that particular postcode. So very easy. Now that we learned about this, we can start thinking a little bit and maybe start to find some information that can be useful in our analysis. So we can get online information about the density population of our postal codes, or the average income of people there, and you can merge them to the data set of the polygons. So now you can plot, instead of the area, you can plot the actual information that you're interested in, like density population. And then on top of that, you can start seeing the distribution of your places, of your cafes around the area of Milan, to try and understand which ones are on more populated area, if that's what you're interested in. Again, you can then put all of this on Folium. You want to select a few cap zones, a few postal codes that you're more interested in, maybe, and then immediately filter only the cafes that are on the postal codes that you're interested in. Another thing that I didn't say is you can immediately add some pop-ups on Folium where you can show the information that you want, the address in this case, or the name of the place, or whatever. Okay, so now that we have used income and density population on this, we should start using it on our actual data set, the places, because we want to start enriching our data set. So each bar should start having, bar or cafe should start having some information that we can use. So we merge the same density data set with our original one. I'm just choosing the main cities, some of the main cities in Italy now, to get the data set smaller, because for what we have to do, we need to, I mean, it takes time. So when we do the merge, we see there are some values that are missing. And that's probably because the address and the postal code especially is outdated, maybe. So we need to decide. We can decide to drop those rows, or maybe find a way to fill them up. So this gives us an occasion to do something else, something that is very also important in this branch of business, which is geocoding. Geocoding is something very useful. It means converting places to locations, so to coordinates, or vice versa, so reverse geocoding, where you start from locations and you derive a synthetic address. That's what we do here. So we try to start from the locations and get the addresses back, and see if the address is more updated than the one we have. And then we merge again, as we did, and we check if there are less unknown densities and incomes as before, and this is the case. So we have improved our data set. And then from there, you can really decide, I'm going to exclude these ones, or I'm going to maybe take an average of the densities of the whole city, or all the postal codes around the one that I don't have. So we're building up our data set. There's a missing piece that is very important here. And I didn't tell you that the geocoding, for the geocoding you use libraries. They're essentially APIs that you use and get the information from things like Openstreetmap. That is an open source library where you can really find a lot of information. You could just download the whole polygon of Milan and then again play the same tricks as we used before. But the interesting thing here is that I can really download a lot of information about Milan in this case. A lot of places a lot of points of interest that I might need in my data set. For example, I can download all the schools around Milan, the ones that are on OpenStreetMap, and then try to play some games with this. For example, I just need to get the bounds of the Milan polygon and download all the schools that are on OpenStreetMap on this. Last thing would be, well, almost last thing, another thing that might be useful, as I mentioned before, the roads. You can download all the roads in Milan. These are residential roads. So you might be interested in cafes that are close to residential areas and residential streets. So you can download also all of this. Finally, what you can do, these are again the schools. You can start calculating the distances between the different schools, the reciprocal distances, or the distances from each school and the centroid, and in this case color them differently according to the distance from the centroid if you think that the centroid of the polygon of Milan might coincide more or less with the city center, right? Schools are just an example, but you can really download everything. So the idea here would be to have our cafes, density, population of that area, income of that area, and then a set of points of interest that we might be interested in. Counting the number of them within a certain radius from your cafe, the distance between them, and so on. So the data set that I built consists essentially in this. The type of the place that I just split into the 4 types with the one-hot encoding technique, the density, the income, the distance between each cafe and the closest one to it, the distance from the centroid, so like from the city center, and then the count of how many libraries, how many supermarket, parking, and so on there are within a radius, I think I chose of 300 meters probably. And then the only thing we missed to try and apply some machine learning would be the target. So I imagined here an income or the revenues that you would make or that you already make with the cafes that you already have as a combination of all these features. Okay, this is obviously a synthetic column that I created just to as an exercise to then apply some models. The main models to use here are really regression models, because what you're trying to predict is the revenue of each cafe once you have all the characteristics that I'm showing here. So you're able to understand if that cafe might be a good choice for you according to how high the revenues are. So just very quickly here, I try to apply, you start by analyzing the correlations between the different variables. Mainly the one you're interested in is the revenue with all the others. I put some high weights for density and income, so it makes sense that the correlation is high, and so on. So you check the correlation and think maybe one is not influential, so you might exclude it or not. And then you apply linear regression. Well, first you need to treat a little bit your data set. You need to split in 2, train and test, and then you standardize your data set to make it easy for the model to make the prediction. So I'm running out of time here, so I'm just going to show you that for each model you decide to use linear regression, you check the coefficients that it finds. There are some that explode quite a lot. This might be because there is multi-collinearity between them, so there are things that you should do to treat them, and then apply the predictions to the test part that you left behind, and then you check the usual metrics that are typical for linear regression, like R squared or MAE and so on. You start from this as a baseline model, and then you try to improve it according to certain intuitions that you might have. So you might apply some a regularization to your model to try to predict the overfitting with this type of regression versions here. You can even try with the simple neural networks just to see if it makes a difference. You can see that the metrics are improving a little bit because they're decreasing. And then I think another choice I tried is polynomial regression, where essentially you add a polynomial feature made from your coefficients. And it seems to work because the RMSA becomes lower. So this is just an exercise, but to conclude, so we have seen location intelligence, how it can be useful. We have seen that geospatial data needs certain treatments because they can be complex, and Python can help us a lot with this. There is a big offer of visualization and mapping tools. We have talked a little bit about retail expansion as a common application and what we can do to frame the problem and try to get a data set that then we can use, and then a little bit of machine learning, just because we are data scientists, so we are always supposed to use a bit nowadays. So thank you very much for your attention.
Thank you, Giacomo. We actually had one question about how do you transform location details into features, so you already answered some of that. And we have a different question. Are there any privacy issues using territory data and analyzing people's movements in territories?
Well, you definitely need to be careful. So with this type of open source tools, there shouldn't be any problems. Like Openstreetmap is really a library that is the users contribute to create. So they're all information, as far as I know, that you can use with no problems. When it comes to real data that might come from clients, for example, internal data, then it's another story. But as I said, you can just use information that are freely available online, and so I wouldn't see. I'm not an expert on privacies, but it should be fine. It should be good.
Okay, thank you. And we have one more question. What tools do you suggest to visualize 3D geospatial data?
Yeah, that's something that I've never done so far, so I really wouldn't know. We were talking before with some colleagues about fancier type of maps, 3Ds. I don't have I cannot give you names. I'm sorry, so I'm not at that stage yet.
Okay. And we have time for one more question, maybe. Is there any alternative to Geopandas for people that don't use pandas that much?
Probably there is, but I would really recommend to get into pandas because they are one of the best libraries I know for data analysis, and Geopanda is just a natural extension of it. So I might find out there are more, but I'm really happy with this, so I would really recommend to go for it.
Okay. And one last question. Is it hard to manage shape changes of geographical data?
Shape changes? I'm not sure what that means. I don't know if the person is...
Do we have a person from that question in the audience?
Changes in shape? Yeah, it's there.
Yeah. What I mean is if some municipality or territory changes, and if it's hard, and for hard I mean you can have highly frequency changing territory, or the sources you have it's not compliant. I mean, for Italy maybe it's ISTAT. You get the shape file, so you have to track the ISTAT website, or do you have a repository that you can count on? And
not really. No, so what I do is I trust. So again, I mean, with OpenStreetMap, you also never really know how updated the informations are. I mean, obviously this is open source. You could use the Google API, for example, and that's most of the time is more updated. And actually, in our daily work, we use that a lot. But the idea here was just to use, stuff that with Python, just with a notebook, you open the laptop and you can go. But obviously, yes, if things changes too fast, probably you wouldn't have very updated results, I'm afraid.
Okay. Thank you again, and it was a very good talk.
Thank you.